So my name is Ryan Sanders. I'm product marketing manager here at KeyFactor. And I have to say, I'm really excited about this one because not only do we get to kind of look beyond 2020, which I think we're all happy to do, but today's panel is also packed full of experts, not just from KeyFactor, but also our partners at Thales and Isara. So let's get started with some quick introductions. So first, we have Chris Hickman, Chief Security Officer at KeyFactor. How are you doing, Chris?
I'm doing very well, thank you, Ryan. Excited to be here today.
Awesome. And then we've also got John Ray, Director of HSM Product Management at Thales, and also Mike Brown, co-founder and CTO at Isara. How are you guys doing?
Great, thanks.
Nice to be awesome. Here. Happy to be here today.
Awesome. Me too. Yeah, this will be a great discussion. And I should also point out that this is the first and probably the only all-Canadian panel at the summit. So just had to call that out. I know we had a conversation about hockey before this even started, couldn't even help it. So, but let's get into it because we've got a lot to cover and not a lot of time. So over the next 30 minutes or so, we're going to be walking through 5 trends that we expect to see in 2021 and beyond. But I think it's also important to just start off with why we're here. So if there's one takeaway from the summit so far, it's that cryptography is critically important to your business, if there was ever any doubt about that. So to set the stage, the use of crypto and PKI in particular continues to grow exponentially. And these assets are foundational to not just operational security, but to new ventures like 5G networks and IoT. So no doubt that we'll touch on a few of those, but just want to start off with a few quick thoughts from you guys on just the state of crypto today. So Chris, why don't you start us off?
Yeah, certainly. I think cryptography obviously is continuing to be adopted very widely. And while cryptography continues to be important, obviously crypto management is the next wave that people need to address and need to deal with. So, everything that's secure today will be insecure in the future. It's an absolute. Why do we know that? Because everything that was secure in the past is probably insecure today. So there's a sort of evolution that happens, and therefore, cryptography continues to evolve. Crypto management needs to continue to evolve, and what we see on the near-term horizon is going to shape how we conduct business moving forward. So I think it's very important that we do look forward and prepare ourselves for that topic.
Right. Your thoughts, John?
Yeah, so I think for me, one thing that we need to realize is that cryptography is there in almost everything we do today. That we don't even know it, but it's a foundational technology, PKI, a foundational technology for things we do all the time, from bank transactions to streaming video to passports to daily activities. It's always there. It's going to continue to grow. As you mentioned, 5G networks, that's more things, more devices, more ways that we're going to require cryptography as we go forward.
Right. And Mike?
Yeah, and I would just echo what John said there. If you think about the fact that cryptography is effectively everywhere and such a key part of all of these types of areas that were just talked about there, it's like plumbing. If you need to make changes to your plumbing, think of how destructive and how much work that is to do to your house then. And so you'll hear a theme of agility throughout this discussion here about to help you prepare for the future. And that's because cryptography is ubiquitous.
Yeah, absolutely. That's definitely going to be the theme throughout. So let's get started then. The first trend that we want to talk about is the resurgence of PKI. So I've heard a few references throughout the conference so far, PKI being referred to as the blockchain of its time. I think we could spend an hour on that, but even over the past year, we've seen a huge resurgence of how it's being used. So whether it's being used to secure IoT devices as well as new DevOps use cases. So John, let's just start out with how IoT and why it's being used, PKI, to secure these connected devices.
So I think it goes back to what we just mentioned, is that it's a foundational technology, that a lot of these infrastructures like IoT, a lot of devices, if you need to identify these devices, if you need to tie them all back to where they came from, update them, the PKI technology gives you that capability. And there's only going to be more devices. So that use of PKI here, that root of trust, to identify all these devices is really important.
Right. And Chris, I know we actually at KeyFactor, we did a research study earlier this year on RSA certificates that are being used in these devices. Do you want to touch on that too?
Yeah, I mean, it came down to devices not having the appropriate entropy to create secure keys. And what we found is, as a result of that, you ended up with keys that were simply, insufficient, if you will, from a crypto standard. They didn't provide enough uniqueness, and therefore could be vulnerable to attack. And I think that's really important, especially in IoT, where you're dealing with constrained devices, generally speaking, long lifetimes. People who buy consumer products, a car, they want it to last for more than 5 years, whereas we might be happy throwing other devices out within that time frame. And into things like medical devices, where you're dealing with them needing to be in the human body for a long period of time. And early generation devices just had too much set and forget crypto, where they embedded in crypto through one mechanism or another, but never looked at how to manage that crypto, as John alluded to, things like the root of trust and so on and so forth. So, the need to be flexible with these devices, to be able to update them, to be able to update the crypto parameters around them, the software around them, and make sure that software is secure, are all parts and pieces where PKI certainly play into that IoT story.
Right. And then beyond, I think IoT is, as I mentioned, DevOps. So we've also kind of, I think, had to redefine the way we think about PKI, if that makes sense. So the world of DevOps, for example, there's many tool sets outside of your traditional PKI that are now have certificate issuance capabilities. So John, I'll direct this one back to you, but have you noticed any sort of trends in terms of the use of PKI in DevOps?
Yeah, I think when you look at the trends, developers are being asked or starting to build in security to their code during the development phase, as opposed to security and crypto being added on after the fact. So taking advantage of these new technologies and different environments where there's a PKI, but these developers aren't necessarily up to speed or competent with security, even though they're trying to add this in. So there needs to be a little bit of communication and work between the development teams and the security teams to make sure that the things are compliant, that things are built securely.
Right. I was going to add to that, if I may, Ryan, that the other trend that I'm seeing, I'm sure you're seeing this as well, John, is this notion of things, because they need to leverage PKI, it's just kind of being built in, and it just sort of installs as a part of the package, if you will. And we've certainly seen that with some of the DevOps tools. And as a result, organizations end up issuing hundreds of thousands, millions of certificates over the course of using those tools that may or may not be in compliance with corporate policy or InfoSec policy. And there is a consequence of that to the organization. And the consequences are slowly but surely starting to be felt as developers leverage these tools. I'll give a good example. HashiCorp has a built-in PKI. When you use their product, it automatically starts issuing certs. It's great. It serves a purpose. But then you sort of get into this push-pull between the security policy people and the developers. And the developers are really, I think, interested, in just doing code and doing code really well. And so if you can make it easy for them to adopt technology, to John's point, and slipstream it in as a part of leveraging those new tool sets, you make it easier for them to stay compliant and eliminate friction within the organization.
Yeah, it goes back to that. Sorry, Mike. The communication, and are the defaults in those tools set properly for what your requirements are? The developer is just going to take the defaults most of the time.
Yeah, John, that's a great point. And I think that brings us nicely into our next trend, which is crypto exploits and the increasing frequency of those, because when these keys and certs aren't handled properly, that's when they can be easily misused or even abused by attackers. So just to lay the groundwork for this one, when we talk about crypto exploits, what we mean is, again, the misuse or abuse of keys and certificates. SSH keys are an increasingly important component of that too, but it also includes unpredictable changes in the crypto landscape. So things like a CA compromise or vulnerabilities in the Cypher suite. All right, so John, I think it'd be great if you could tell us just kind of some of the risks involved in code signing certificates in particular.
Yeah, so code signing certificates, you think about what that does. It makes sure that software or firmware comes from a legitimate source. You can think of the problems that may occur if somebody can compromise a key or certificate, sign code which looks valid, but then gets to a device, and the problems that that can cause.
Right. And then when it comes to SSH keys, we're definitely having a lot more conversations around that. So the fact that admins can go off and really just generate their own keys, it's not like PKI where you have to request a certificate from a trusted authority. It's really up to them to generate keys on their endpoint and put those public keys wherever they need access to. So that really becomes an issue in terms of the misuse of those. And then also TLS certificates, of course, the same problem really is kind of across the three of these: visibility, not knowing where those certs are, what compliance state they're in, and how close they are to that expiration date. That creates a lot of problems and potential vulnerabilities. So on that note, let's go into it. So this is by no means an exhaustive list, but we've laid out kind of a rough timeline of some crypto incidents over the past decade or so. And John, let's talk about some of these. What are your thoughts, or any of these that you'd like to call out specifically? I know Stuxnet is pretty familiar with our audience, and there's quite a few that might pop out, but any that you want to talk about here?
Well, Stuxnet it's kind of the granddaddy of somebody getting access to a code signing cert and having software which looks legitimate cause major problems. So that's the key to me. Heartbleed goes into the TLS certs and that ability to impersonate a web server. Chris, what do you see from this trend here? This list of
I mean, all of these are very legitimate concerns, obviously, and what really jumps out at me though is that this is a 10-year timeline. If we look at the spacing of the dots and how many more appear, if you will, towards our current timeline, I think that there's an interesting note to take away that we're either getting better at detecting them, which I hope we are for the sake of security in the community as a whole, but I think they're also happening much more frequently. So I think in that respect, it's an interesting takeaway to sort of look at how these trend lines are developing, and there is momentum behind these types of attacks and the risk that they present. Mike, anything to add to that?
Yeah, all I would say there is that trend of them coming together faster and faster, and it's also showcasing the fact that threats happen at all layers of the stack, everywhere from looking at the administration of a system which is utilizing code signing keys all the way down to potential compromises of the fundamental algorithms being used. Like, this is so much more of a challenge for an administrator to manage.
Right. And in terms of trends, I mean, you just mentioned that too. Code signing, you can see these all the way from Stuxnet to the Advanced Persistent Threat Group, APT41. They're pretty infamous now. There were 4 of them that were recently indicted, actually. But these nation state or state-sponsored attacks, there's quite a few of those that we're seeing kind of pop up, and I mean, companies don't really have to defend themselves against nation states physically. There's nobody at their walls waiting to break in, but when you think about virtually, there's just so many doors that they can come in from, and code signing in particular. We talk about the theft of keys. That's one. I mean, Bit9 in particular is a great call out there. Is they thought that there was a VM that was just dormant. Turns out an attacker was able to get into that VM through an attack and found it, and easily was able to misuse that code signing certificate against their own customers. Adobe, another case. So in that case, they actually were doing it right. They were storing their code signing certificates or the private keys in an HSM, hardware protected, but they didn't secure the process around that. So it was actually the signing breach or the signing process that was breached. And then also with ASIS, we've seen that too. And another thing to call out too is we talked about developers earlier. I think a big problem that we're seeing more of is just hard coding these into applications, or in the case of D-Link, where they accidentally publish a code signing key in their firmware. And then lastly, just another trend to note is the attacks on Linux. I think we're seeing more malware that's specifically being modified or designed to target Linux, and SSH is a core component of that that they can kind of exploit. So whether that's brute force attacks or stealing the SSH private keys, or even injecting a SSH public key into the authorized key file so they can have persistent access into that network. I think those are some critical issues that we're seeing come up, and SSH is a relatively kind of under recognized area of security, I would say. Chris, just before we jump into the next trend, any thoughts on that? I know we've had more conversations around those in particular.
Yeah, I mean, I would just caution everybody. Lesson to learn from all of this is just code signing keys and SSH keys are things that are prevalent in the organization. Most organizations have a lot more than they need, to be very frank about it. They don't have a good grip on where they live and what they are. They may or may not be in hardware, and they are incredibly impactful. And at face value, it's just a key. It's just something we sign code with. But once that falls into nefarious hands, and code signing keys are one of the most expensive things to buy on the dark web today. And there's a reason why. And APT 41 certainly taught us a very quick lesson about how the impact of wrapping malware in legitimate code signing keys that in this particular case started in the gaming industry as an example, led to a really predominant proliferation of that malware and opened up a lot of backdoors. And SSH keys can be very, very similar along the trend line. So it is something that organizations really need to be aware of moving forward. And I think when we're back here next year, there's going to be a lot more dots in the year in the space of 2020 to 2021. Prediction, if you will.
Right. Yeah. Got to have a few of those. So let's move into trend 3 then. So shorter certificate life cycles. And this is something I know our customers have been asking a lot about. And Chris, you've been having a lot of those conversations. So what does shortening certificate lifespans look like? And what is the impact of this on organizations come next year?
Yeah, I mean, the reality is that, for folks who are not familiar with this, relatively recent but very impactful change where Apple, Google, and Mozilla basically strong-armed, as the headline says here, into the CAB forum, a change to the recommended lifecycle for publicly rooted SSL certs. And they reduce the lifecycle of those. We're prepared to reduce the lifecycle of those arbitrarily from basically 27 months down to 13 months, which is huge. And as this slide very effectively shows, over a period of 8 years, there's been a reduction, a significant reduction of the lifespan of the certs. And while the intention of this is completely honorable, this is really in the interest of protecting people who struggle to manage certificates and keys, the reality is it's increased the burden of managing those certificates and keys over the course of each iteration here and each reduction in lifespan. So now we're down to basically a year. You've got 1 year in which to renew all of your SSL certs. So every year you're going to be rolling over all those SSL certs that are publicly rooted that you're getting from your third-party publicly rooted vendors. And the comment that I'm getting from a lot of people is, my workload just went up 100%, but my budget to manage it did not. How am I going to manage this? Because in a lot of cases, organizations have thousands of these certificates within their organization. And the management just got extremely complex with those, because the consequence of not rolling that over is an outage, of course. And outages are something that are even more expensive to an organization to bear. So the disruption associated with this could be become very significant. And we have yet to sort of see. It'll be interesting to see in about a year's time what the net effect of this change is when everybody sort of enters that 1 year window and has to suddenly deal with the consequence of suddenly trying to get these done, especially if they're not leveraging things like automation. And this slide that you put up, and thank you, Ryan, shows some of the more notable ones. I mean, recently we had a big Teams outage. Everybody heard about the Spotify outage. These are things that are very disruptive to organizations, but also disruptive to the brand of the organization that publishes this software. And what's increasingly happening here as well is it's not the public-facing web server certificate that is actually failing. It's a combination of other certs in the background that are being used to authenticate, do mutual authentication, for instance. Client certs that are talking to SSL servers that you may not see. It's not what pops up and makes the lock green on your bank's website. It's what is securing all the background communications. When those client certs expire, there is outages. And so the proliferation and the use of certificates for good security is fantastic, but not being able to manage those certificates also leads to this consequence. And I'm curious to get Mike's input here too. Do we, from your expertise, for instance, in quantum, do we think this trend is going to continue? Do you predict and see this trend continuing as we get closer to quantum supremacy?
Yeah, what I think we're going to see more and more of is, as we highlighted in the past with the transitions related to hash functions, going from MD5 to SHA-1 and SHA-1 to SHA-2 and so forth, there is that these types of disruptions which are caused by changes to your certificates under the covers, then we're going to have more and more reasons why we're going to need to do those. And some of them are going to be crypto, so core math related within them there, which is just going to put more and more pressure on the need for strong management of the assets that you have.
So I mean, again, this is just something that administrators are having to deal with. They're not getting the extra budget to deal with it necessarily. There are solutions, obviously, that they can leverage to do it, but awareness, it starts with awareness, and people need a plan to deal with this, or come September 2021, there are going to be significant outages impacting organizations.
It's about around awareness and processes and planning.
And speaking of planning, that's actually great, because this next one, I think it's, Chris, you mentioned predictions. This is probably one of the most predictable yet under-recognized trends that we have in this list, and that is root CA expiration. So can you talk a bit about, I mean, we've referred to it as a sleeping dragon. Others have said the impending doom of root CA expiration. Can you talk a little bit about that and why we put that on this list?
Yeah, so I'm just going to draw attention to the graphic here on this slide, and what we did here is we just took a quick screen clip of the cert store, the root cert store of a Windows machine, Windows 10. And what we're showing here is between now and the end of 2021, the root CAs that are set to expire, and therefore the certs will no longer be trusted that are issued from, or chain up to, I should say, these root CAs. And if you look at them, there's some fairly significant ones there. We just recently in May saw the AdTrust root CA expire, and it was very interesting to sort of see what happened to a lot of devices that were counting on the chain up to that root CA, and many of them honestly failed. We had outages from products like Roku, and there were some smart TVs that had issues, and so on and so forth. And it came down to a simple concept of without updates to software taking place, it's hard to manage roots. And what has traditionally happened is, in order to manage a root, I push you a new image. And we're not actually yet at a point in a lot of product type spaces where we're actually managing the root stores effectively. We're relying on full images of software to push that out. And so as a result, if you didn't update your legacy Roku or devices like that, you had an outage. There was no way for them to push to you just an update to the root store. If you think about what's happening then looking forward into things like autonomous vehicles, imagine the consequence of something like that happening. So you can very quickly start to see what the impact of these are. But what organizations need to realize is that managing the certificates is important. Managing the root store is equally important. There are things going to be coming down the timeline that are going to force you into a position where you've got to update root stores, and you've got to do that in an effective and efficient way. And you've also got to look ways to do that into non-traditional OSs, like embedded OSs and systems like that. A couple of main drivers we're seeing here is not only the expiration of these CAs, but then there's also this Unix 2038 limitation, which is like quote unquote the Y2K for Unix. There's a lot of forks of Unix that are out there in the form of Linux, in the form of even Mac OS is a Linux-based system. And while some of these have taken steps to address this problem, the problem is that come January 2038, it doesn't recognize the dates anymore in a 32-bit environment. So if you think of how many things have embedded Linux in them, or embedded Unix, this is going to be a problem where you're just not going to be able to recognize certificate chains and CAs that expire beyond those dates, or that are valid beyond those dates, and it's going to reset. And it's poised to be a very big problem that is largely getting ignored. The the way to deal with it, quite frankly, is to be able to manage those root CA devices. And I know, Mike, I'll come back to you again on the quantum side of things, which we don't have a definitive timeline on, unless there's been an update on your side. But the reality is, I mean, it's pushing a similar type of problem space.
Yeah, and what I would add is in a previous lifetime, I spent 14 years at a smartphone manufacturer and got to deal with root certificates from the perspective of an actual manufacturer. And one of the complexities that we sometimes don't think about from a manufacturer's point of view is it's not just a .cer file. It's not just, oh, there's a new root cert, I update the file there. You have to think about there's legal agreements with CAs, there's QA cycles, there's support contracts. If you have enterprise customers, you need to make sure that they're ready to take changes that are coming into the products they use there. So these impending root CA expirations, we need to make sure that we give them the proper time to make sure that the transition will be more successful, because everything takes longer than you think it will.
And to that point, actually, I was just reading the other day that Let's Encrypt has pushed out their new root issuance out another year because they haven't seen deep enough propagation of the new root across things like Android devices, and they're concerned that if they push that out, there will be a break in that chain. So it is actually a big problem. The other part of it is too, there's certain roots you should be getting rid of. So by the same token, I recommend to customers look at what devices trust and manage the trust that you want in those devices, and be able to continuously update that based on various different threat vectors, expiration in crypto or deprecation in crypto, changes as we sort of come into this new realm of quantum computing. But in addition to that, just getting rid of garbage out of there from legacy CAs that honestly just should not be trusted anymore within the organization or within your products.
Right. And so I think this one is tied to dates, right? This is something that you can plan for. And the next trend that we're going to talk about, I think we couldn't help but mention it a few times, but that is quantum, crypto apocalypse I put here. But the idea here is again, the disruption that this could potentially cause. And while this is never easy to predict, there's always those questions: when will quantum happen? When will quantum supremacy happen? But I think despite when, I think there's always a plan that needs to be in place. So John, this is really the world that you live in. So can you tell us a bit about quantum and what we can expect in the years ahead?
Well, I think it's definitely a world that Mike plays in. But,
sorry, Mike. Yes, I knew I'd do that once.
Yes.
Right.
So I'm happy to talk about it then. What's interesting is I think the general population hears about quantum as this sort of boogeyman that's coming then. And the reality is often a little more nuanced than that. Quantum computers are fundamentally a different way of doing computing then. Let's exploit some properties of physics in order to compute in a different way. And the stage we're at in terms of building quantum computers is very much like the early days of digital computers. We're trying to figure out what the transistor is going to be for quantum computers then. We use terminology like qubits and quantum volume and all of these new things, but we're still in the early stages of understanding what is that scalable architecture going to be to build quantum computers that can then exploit the algorithms we've designed. And the reality is you probably aren't going to have a quantum computer in your pocket. Probably the better way to think about quantum computers is like a graphics processing unit. It's going to augment what we do today, because quantum computers can solve some problems really well and other problems not as well then. Unfortunately, and why we're talking about it today, one of the problems that it can solve is the math that underlies public key, the PK and PKI. And so the challenge that we run into then is that we have to start thinking about how do we do transitions, what do we move to then, especially with we see the progress that big companies like Google, IBM, Microsoft are making, and smaller companies like Rigetti and IonQ. IonQ, for example, just had an announcement over the last few weeks about showcasing new breakthroughs in measurements called quantum volume of how well their computation is going then. So if we go to the next slide then, there's a need here to really start thinking about what do we protect ourselves with? How do we sort of change things in order to make sure that we're using public key cryptography that is safe from quantum computers? And cryptography is ultimately a language. and it's a language that we specify using standardization processes around the world. And the one that probably a lot of people are most familiar with is the NIST process. So NIST in the US, the National Institute of Standards Technology, and they focus, among other things, on specifying what the cryptography is that we use to communicate specifically with the US federal government, but it's used broadly. And they're a few years into a standardization process of actually specifying what the new so-called quantum safe algorithms are going to be. We have sort of primary and alternative candidates here, but the important part for customers to understand is that we're looking at somewhere between 2022 to 2024 for actual draft standards. I also want to highlight that it's not just about NIST. If you have cryptography as a language, you have to start understanding what's the grammar for the language. How am I actually going to use it in communications? Things like the IETF for how the internet works, ETSI for how our cellular communications work. This is a change that needs to impact so many parts of the fundamental way the internet works. And the message is that, like all big changes, this is going to take a while for you as a customer. And so this is very much a planning stage for you now to start thinking about how to protect yourself.
Right. So those are our 5 trends. We've covered a lot of ground, I think, but I think the biggest takeaway here, it really just goes back to the theme of our entire summit and back to what you said, Mike, at the very beginning is crypto agility. So many of the things that we've talked about can either be addressed today or, as you mentioned, planned for in advance. So every key, every certificate, algorithm will need to be swapped out, whether due to expiration, a vulnerability, or advancements in quantum, and we need to start thinking about that. So in this part, let's each kind of have our say here, but I'd like to give you a shot at just either doubling down at something we've already talked about, or if you think we missed something. So Chris, let's start with you.
Yeah, I mean, to me, all of these trends lend themselves to having a plan. Making sure that your organization is aware of what you've got in your environment, or if you're doing product, what is in your product and your product environment. Making sure that you can suitably adapt. I mean, a lot of people are sort of looking at big bang things, and I would put quantum in that category, but there's a lot of little things that happen every day. And Mike, if I'm not mistaken, you referred to SHA-1, SHA-2 as a good example, and it's a great bellwether by which organizations can look at how did they handle that transition. How well prepared are they for the next thing that's going to happen and the next thing? Because there's 2 types of events: the ones we can plan for and the ones that happen that we have to respond to. And both of those come into account. So my key takeaway from this is be able to look at your organization, be able to look at where all your crypto assets lie within your organization, be able to identify what they are, and have a plan to migrate them, and make sure that you've got the correct policies, procedures, and even technology to be able to do that in a very timely and efficient way, so that you do not introduce new risk to your organization. And if you see something coming over the horizon, get on it quickly. This stuff does take time. There is no big easy button to solve these types of problems. And make sure that you're asking your vendors the right questions as you're acquiring products, their ability to be able to adapt, to add to your crypto agility story versus becoming a burden to it.
Right. Yeah, that was great, Chris. And John, curious to get your thoughts given some of the exploits that we talked about earlier.
Yeah, so from my perspective, and it's to add to a lot of what Chris said, is that cryptography is everywhere. It's being used in a lot of places that you don't think about today, but in our daily lives, we see it all the time, and it's only going to expand. And that's going to mean more keys and more different algorithms, lots of different algorithms. And you need to be able to plan for how that's going to change over time. How are you going to ensure that you're crypto agile, that you've planned to know where your keys are, what they're being used for, and that you're able to change that over time, to modify what algorithms are being used, to modify how you manage those keys, to modify how you protect those keys, to make sure that you're ready for the future.
Right. Yeah, that's a good point. Crypto is everywhere. I think Simon Hunt said it best on our panel yesterday. He just said you just can't get away from it. So, Mike, what are your thoughts?
Yeah, my biggest takeaway here is just for you to recognize that any type of large-scale crypto transition, this is a large IT project. And so they take time. They take a long time. You know, federal governments will take anywhere from 13 to 20 years to do a large-scale crypto transition. You know, banks that we talk to are typically forecasting 7 to 10 years. If I'm a car manufacturer, I'm thinking about 20-year duty cycles, you know, from design and implementation to actually being on the roads as well too. There's a lot of time associated with this, but step one is always do that inventory, do that archaeological expedition to find out what you have in order to make sure that you can change what you need to.
Yeah, exactly. And back to Chris's point, I would just say something interesting that kind of came to me as we were going through this is, if you've heard the analogy, the $2 million machine breaks on a $2 part. A lot of it does go back to the simple things, as you guys have mentioned, having a complete inventory. When it comes to certificates in particular and keys, they can be located in more than one place. So understanding all of the locations of those, how they're being used, which applications are using them, as Chris mentioned, knowing your third parties and what their plans are too, I think is critically important. So that was awesome. Thanks guys for that discussion.